sailed the sea to make preparations for the 2014 Winter Olympics. Our purpose is to introduce you to the project of strategical importance for the economic development of the Sochi region. The idea of installing a gas pipeline along the Krasnodar shore took place at the beginning of 2000, but the final kick into taking the decision was the selection of Sochi as the host of the 2014 Winter Olympic Games. The Zuga, Lazaretskoye and Sochi gas pipeline is part of an intensive development program for all the Russian resorts on the Caucasian Black Sea region, and is included in the program approved by the government of the Russian Federation for construction of the Olympic facilities and the development of the mountain resort of Sochi. The Russian company Gazprom is the beneficiary of the gas transportation pipeline.
This is a project that consists of 150 kilometers of pipeline, and it goes from a town called Zubga down to Tuapse, and from Tuapse down to Kudepsta, which is close to Sochi, whereby the Olympic Games will be held year 2014. One of the most important things for this gas pipeline is the distribution of the gas, so the infrastructure in the country can be improved and they can prepare for the Olympic Games.
With a total length of 177 kilometres, out of which an offshore section of 159.5 kilometres, the DLS gas pipeline is installed on the seabed, along the shoreline at a distance of approximately 4.5 kilometres, having its final point of termination at the gas distribution facility in Budapest, in the vicinity of Sochi. GSP is the only Romanian company to win a project of such a scale in the Russian Federation. The initial value of the contract amounting $269 million. The 530mm gas pipeline will have an annual flow capacity of 3.8 billion cubic metres. The offshore natural gas pipeline project was designed in such a way that it should be distant from the coastline as possible, in order to guarantee the substantial mitigation of the environmental impact on the Black Sea coast ecosystem. DLS is a multicultural project comprising of people of various religions and ethnic groups, as well as an extensive professional range, from fitters and welders to NDT technicians, ROV operators, divers and diving support operators, marine crews, designers of pipelines, oil and gas installation and commissioning engineers. A great variety altogether. A great number of nationalities have come across in this project to bring together their engineering expertise. Romanians, Russians, Dutch, British, Thais, Malaysians, Italians, Spanish and many more. The construction of offshore projects was under GSP's coordination. GSP carried out the main offshore works in approximately 100 days between March and July 2010. GSP has experience of large-scale projects and projects of outstanding importance. DLS wasn't in any way a simple project.
I consider that this company is a leader in this part of Europe, especially in Black Sea, regarding the drilling industry and the pipeline. Our job, the Bigfoot One job, is to lay pipe in Sochi.
The last 5% of the project works were completed in May 2011. Once the connection of the offshore and onshore sections of the DLS pipelines were completed, GSP Bigfoot One performed the final middle tying, welding together two sections of pipeline near the Kudepesta settlement. Previously, similar works were performed near Tuapse, Zuga and Novomihailovsky. The onshore-offshore connection of the DLS pipeline, Southern Loop, then followed by pressure testing, dewatering and drying. The testing and drying of the Northern Loop in Zuga-Tuapse section had already been completed. You may become aware of the dimensions of the DLS project once you learn about the offshore section, which weighs 84,000 tonnes. GSP's offshore technological camp was quite something. An extensive international fleet mobilised offshore of the Caucasian shore at about 4.5 kilometres. Two pipeline barges, GSP Bigfoot One built in 2010 in GSP Shipyard and Seamaster. GSP Prince, the most modern OSCV and DSF ROV in the Black Sea, built in 2009 in Norway. GSP Phoenix, PSV, intended for manpower and materials delivery. GSP Vega and GSP Queen, the anchor handling tugs. A 12-man, 300 metres of saltwater saturation diving system. A fleet of ROVs for pipeline route surveys, as-laid surveys, monitoring of trenching and divers operation and subsea installation works. The gas pipeline fabrication process consists of several stages. The pipe laying barges ensure the entire pipeline fabrication and technological processes. Beveling, automated welding, non-destructive testing, coating testing, and finally the pipeline launching out of the stinger to the bottom of the sea. The pipes are transferred from the storage area with the help of a special pipe conveyor system, beveled and immediately after that automatically welded. Once examined for flaws or defects at the NDT station, a welded joint is treated in a special way to ensure protection from leaks or mechanical damages. All these operations are performed on the firing line. After that, the pipe is launched onto the seabed using the stinger. The entire process lasts approximately 8.5 minutes. Thus, every 8.5 minutes, the gas pipeline gets 12.2 metres longer. While the vessel moves at exactly the same speed, it is almost impossible to notice the vessel movement. The pipeline grows slowly, with approximately 2 kilometres per day. Taking into consideration the offshore mobilisation works, words like slowly have a new meaning. Technologically speaking, a 2-kilometre pipeline installed daily in normal weather conditions is quite something. The onboard pipe supply for the fire line fabrication process is stored on the main deck, neatly stacked in lines occupying up to dozens of square metres. GSP Prince looks impressive, and we can assure you it is. It is the most modern OSCV, DSV and ROV from the Black Sea. It was built in 2009 in Norway. The vessel can operate in extreme weather conditions. It can perform tasks such as underwater inspection of cables, routes and pipelines, with ROVs, seabed mapping, subsea installation works, diving operation support, geotechnical studies and manned and unmanned subsea vehicles, support surveys, inspections and investigations. GSP Prince was the main ROV and DSV support vessel in this project. In order to lay down pipes, you need a pipe supply, and the pipes are stacked on the deck. The standard dimension of the pipe is 12.2 metres, and at this diameter they weigh 6.4 tonnes each, including the cement coating which ensures the negative buoyancy of the pipeline. All the pipes are manufactured at the Vixa Steel Works and coated with concrete at the Moscow Experimental Pipe Procurement Plant. They are brought onto deck and stacked in zero bay by the joint handling NOV crane. The pipe joints are stacked in special racks and the same crane moves them onto the production line. The first operation is a quality inspection. The purpose of this operation is to inspect the entire surface of the 12.2 metre long pipe in order to discover any fabrication flaws or deformities caused by handling. Although the impressive size of the pieces, small irregularities may look unimportant, but due to the harsh environmental conditions at the bottom of the sea, any small problem may evolve in time, generating complications. This is why, at the QC station, the inspection is done thoroughly. Pipelines are aligned and directed to the preparative workstation 1 for the J-type bevelling operation. Here the bevelling is performed with 2 hydraulic cutters simultaneously operating upon both free ends of the pipe. The picture is pretty simple here. The equipment you see is exactly what is needed in order to lay down the pipes. A heavy lift crane, a Liebherr 318-ton lifting capacity, an NOV pipe handling crane, conveyor rollers, an S-lay stinger, and a brand new fully operational firing line and an army of perfectly trained operatives. This is the first pipe segment, and 6 working stations away it will be placed on the seabed. In this particular case, for reasons that will become clear later, the pipe section has a launching head at the start. This is designed to sustain the traction tension of the entire pipeline, ensuring its tightness in submersion, but we'll get back to this. The pipe sections are rolled on the firing line or the fabrication line. The most important operation, welding.
We have here 3 welding stations, 3 complete welding stations. In the first one is the one is the most difficult because we need to adjust the pipe, make the line up, put together, and then we weld 2 passes, the root pass and hot pass. When we finish, we press the green light, and if all the stations is in green color, the pipe moves to the next station. Then the pipe arrives to station 2, and then in the station 2, they weld another 2 passes.
In order to ensure the welding quality, they preheat the pipe to 150 degrees centigrade using an induction coil. After its completion, the pipe sections enter the fabrication process. The correct welding operation has a number of compulsory stages. The pipe sections are aligned with support of the pneumatic device, which ensures all of the dimensions and alignment requests are observed according to procedures. A complete joint includes 5 welding rings or passes as follows. The first one is called the root, and then comes the hot pass. Afterwards, fill 1 and fill 2, and the last, the cap. Referring strictly to the pool in operations performed at coup de pesta, the above mentioned stages were performed in the following sequence. Welding station 1, root and hot pass. Welding station 2, fill 1 and 2. And still going exactly as the welding chief said to station 3, where they applied the last welding ring, the 5th. No matter how thorough the job is done at the welding stations, there is always a risk taken into account. This is why the pipe goes to workstation 4, where a non-destructive ultrasonic testing is performed. The QC team inspect the welding for gas bubbles, lack of penetration, lack of fusion, porosity or cracks, for example.
We start with check all the pipes inside the fire line, and we check the dimensional, check pipe numbers and bevel for on both sides. After this, we supervise all the activity on 3 stations, welding stations, along the fire line, and when we finish all these activities, we supervise the coating activities on the stern of the barge vessel.
Nothing escapes the automatic ultrasonic testing equipment, and the data is analysed and saved. In this case, as hoped for, there is not even a minor quality issue with the welding being checked. And speaking of the QC, there's not a single point in the entire process where they are not present and involved. Welcome to the 5th station. Here they perform the cleaning operation. The welding is cleaned as well as its neighbouring area and the protective layer of pipe. Here at workstation 5, the welded section of pipe is prepared for the application of anti-corrosive protective layer. From this point forward, what we call the pipeline arrives at the tension area. The tensioners are highly important for the pipe laying process as they are controlling the pipe launching from the barge into the water. Here the curvature radius of the pipe is monitored from the moment the pipeline leaves the last roller of the stinger, as well as the curvature radius of the pipe at the seabed contact point on the predetermined pipeline route. By contrast with other places and processes where speed is the most important factor, here the clamping and launching tension matters most. And just how strong do you think the tensioners are? 80 metric tons each, that's how strong. 2 train locomotives on each side could not hold the pipeline as well as the tensioners do here. Let's return to the firing line. We're here at workstation number 6. Here, in the process of protecting the welding, an extremely important element is added, the heat shrink sleeve. The easiest and most effective way to do it? With a gas lamp. The heat shrink is applied over the uncovered area of the previously cleaned metal surfaces exposed to the welding process. The sleeve has the necessary width to cover the unprotected area. Being heat sensitive, it shrinks over the design area under the gas flame exposure, leaving behind a perfect filled joint coating resistant to corrosion in time. It is obviously a little bit crowded at workstation 6, but there are 2 more operations carried out here. Firstly, the pipe that goes into the mounting casing is wrapped in stakes, or as everyone calls them, crocodile tails. This is for obvious reasons. And secondly, for the concrete coated pipe, due to the fact that the cement filled joint coating is thick, the protection area had to have the same thickness. This is done with foam injection. Step 1. They cover the area with a metal sheet. Step 2. Final fixing of the metal sheet. Step 3. A little more predictable. They inject the foam. Now let's stop for a minute and see what this is all for. An onshore approach section. So a total of 1,800 metres of pipe. 1,500 metres have a polyethylene protective covers. 300 metres have a plus of cement coating. Out of this 1,800 metres, 1,500 metres are pulled through the casing that awaits already on the coastline. From the shore site end, a drill string is sent down. Slowly it goes out from the underwater casing, being pulled along by GSP Bigfoot 1. Remember the launching head? Now we go back to it, because it's time for action. The drilling string is attached to the launching head, and again, slowly, very slowly, 1,800 metres of pipe go back through the directionally drilled casing and up into the mounting. Simple as that. Actually it is, but only because thousands of incredibly beautiful minds previously worked their brains out till this process is just right. Impressive. Once the pipeline leaves workstation 6, it is ready to get into the water, but not until getting the OK. Each workstation is endowed with a control panel with ready and work in progress commands. While one of the red lights is on, means that somewhere on the firing line someone is still working. Depending on the works being performed at the time, the station operator enables or disables the station status. Immediately all operations are completed, the green lights appear. Of course, the launching of the pipeline into the water is performed according to a perfectly designed process, with the support of the stinger. It does not only sustain the pipeline, but also controls its curvature radius. The curvature radius is highly important. In fact, so important that this process doesn't have a name but two. The superior part of the S pipeline designs into the water is called the overbend. The inferior curvature is the sag bend. So, they have just finished welding the last piece of pipe, but before they perform the connection between this one and the one already at the bottom of the sea, the preparative is made in order to test the pipeline. The pigs rush in. The pipeline internal gauges are basically big cylinders with the same diameter as the pipe. Using water pressure, the pig pushes the device throughout the entire length of the pipeline. And if everything is okay, they come out the other end in perfect shape. Actually, they did come out intact. But the workflow is not yet complete. For protection purposes, the pipe must be protected and buried in sand. For this, they use a jet air tool.
In the final phase of the operation, the pipeline will be trenched from the casing exit to the tie-in area on a distance of 300 meters to a depth of 1.5 meters. This work will be performed by means of a jet sled machine. Operating at high pressure, the machine will dislocate the soil, leaving behind a desired trench depth which will protect the pipeline in the future.
They put this tool over the pipe. The water is pumped at 20 bars and the sand is displaced, and the gravity does the rest and sand settles down over the pipe. Sure, now it is hard to see what otherwise is obvious in this big technological marine adventure. As the anchor foreman said, it seems chaotic. Well, maybe it might look like searching for a screw in the haze of pipes and anchors, but as the foreman added, it's highly controlled chaos. So in the end, it is all for a big purpose. Though it's not visible under a metre of sand, the pipe is extremely important for this developing area. We have a few loose ends now to try to clear up. How do they make a joint between two subsea pipelines? We have a name for this operation, midline tie-ins. Let's see how the offshore installation and welding engineers figured it out, or even better, how they do it on board GSP Bigfoot 1.
Lifting of the pipeline end will be carried out using the 6 davits installed on foundations of Bigfoot 1. Davits will lift the pipeline ends above waterline in a safe manner so that welders can perform the tie-in weld.
6 divots are installed on the technical vessel. 3 of them hold the previously made pipeline section, the other 3 the newly made pipeline section. The both ends are held above the water at the deck level, one end facing the other. First they take off layer after layer of coating. Concrete and metal reinforcement structure, then polyethylene layer. Then, with the support of an external line-up clamp, they perform by hand one last weld. Be assured the handmade weld is as good as the automatic one. Those guys know their business. They have sealed pipelines all around the world. After the weld is complete, filled joint coating is applied to protect the tie-in weld area. There's another operation to be performed in order to consider the job ready. The pipeline has to be placed back on the seabed. In order to compensate for the loop made when the two pipeline ends are taken into the sea, GSP Bigfoot 1 performs a side movement and lays the entire pipe on the bottom. This is one of the moments when the ROV enters the stage.
This is Mohican. It's a light world-class inspection ROV and it has fitted a Hydrolec 5-function hydraulic manipulator, a seeking sonar, silicone intensified target black and white camera, a color zoom camera, able to operate at 2000 depth of seawater with 130 meters of working tether.
Because of this subsea robotic vehicle, any problems that might appear after the pipe enters the sea could be instantly spotted and rapidly resolved. Throughout the process, the technical vessel must be highly stable. 8 winches control the pipe layer station, keeping it stable. Here's the place the 8 winches are controlled. This way, 8 thin tentacles with 8 anchors at the ends cling onto the bottom of the sea, with slow movements carefully calculated and verified by computerized survey systems, lead the barge the required direction. Each anchor winch has a tension capacity of 80 tons. Each anchor has a weight of 10 tons. For this kind of floating technological camp, you might take into account that it becomes compulsory to use some impressive pieces of technology to control it. Now let's have a look over the place where the pipe goes, the seabed. That place is not always a pipe-friendly place. For that you need a special ship. GSP Prince is an offshore support vessel, perfectly equipped for this kind of job. First it surveys the bottom, and well-trained men decide where the pipe should go. For that they use an impressive ROV, Triton XLR, and his little brother, Navajo.
The system is about 125 horsepower, roughly. It's got a 2,000 meter rating for depth. It's got 2 fully functional manipulators, one 7-function and one T4 manipulator.
If the seabed is good to lay pipes, but not good enough, the divers team is called. Sometimes they actually have to excavate into the seabed so the pipes don't bend or fracture. It is important to identify solutions to answer particular challenges, as in offshore installations it is important to handle the troubles, and GSP Prince can handle heavy problems. Divers may be mobilised for subsea surveys, installation, decommissionings. They are an outstanding professional body. This time they perform a subsea welding operation. The outstanding well-trained divers team can go deep underwater and weld in such a manner they make us believe it is a normal thing in the world. First they have to stay in hyperbaric chambers. The length of the interval they actually live there depends on the diving depth they have to reach. Yes, they are a special breed.
We have the diver here in the bell. He monitors the diver's gas. And the 2 divers, you can see their umbilicals are going out to the bottom, and they are now in the habitat. The habitat has been blown dry, and you can see the 6-inch pipeline here. And right now they are halfway through the first weld, the root pass on the first weld.
Without leaving the pressurised tanks, they enter the diving bell and go deep to the bottom of the sea. Sometimes they reach hundreds of metres of salt water. This system is rated for operation in 300 metres of salt water. Everything is constantly monitored. The air inside, which is actually a gas which makes you speak like this. The sleeping hours, the food that enters through here, and of course their health. Sure, GSP could choose an easy way. 2 welders sitting on the pipe and welding. But no, they went the last mile. The welding is done in perfectly controlled environment, the hyperbaric subsea welding chamber. After completing the subsea survey with the ROV DSV GSP Prince, the place is ready for the next step, laying the pipe. But we've already been there. So this is how things were done from GSP's perspective. But you cannot honestly say that things are done till the client says so. So let's see if the client is happy. Right now, the gas flow through the pipe is on standby. But in a matter of seconds, the entire system, pipe and gas control units, will start running. For this, the Gazprom Vice President and Russian Prime Minister are present.
Уважаемый Владимир Ильич, прошу дать команду на пуск газопровода и розжиг контрольного факела.
Начинайте. Выполняю. Охранный кран открыт. Узел редуцирования в работе. Газ на розжиг подан. Газопровод в работу введен. Поздравляю вас.
Yes, it looks like the pipe and the entire DLS gas unit is running as it should. Now let's return on GSP Bigfoot 1. Because now the job is done, the waters are cleaned, everybody's safe and sound, but for BF1 is surely not the end, as next time we will meet upgraded GSP Bigfoot 1. This station is managed by a brand new dynamic position class 3 Kongsberg system. This floating technology island has already set compass to another project. So see you next time, next job.